Hello, everyone. I am Jared Thornton, and here's my presentation for Lab 1 of Physics 2. This lab deals with charged everyday objects and their interactions. The goal of this lab is to observe the transfer of electrons and determine the amount of excess charge on a piece of charged clear tape. So basically, we're going to create pieces of tape that are charged and observe their interactions with each other, then with other objects that are differently charged. After doing this, we're going to apply the concepts we've learned in class, such as Newton's law, electric force equations, and electric field equations, all to determine how much excess or deficient charge is on the tape. Also create a glow script model of the interactions. Some concepts and equations we'll use for this are Coulomb's law, which tells us first that similar charges repel while opposite charges attract, and also that the electrical force between two charged objects is directly proportional to the charge on the objects and inversely proportional to distance between the two objects. Also, the conservation law of charge, which states that the charge can't be created or destroyed, only transferred between objects. We also remember that neutral objects are attracted to charged objects, and other equations include the ones shown on the screen here. So the electric field equation, force of gravity, and the equation for Newton's second law. When it came to the procedure, I cut pieces of tape and laid them down on top of each other. It is important to touch the tape as low as possible so you don't transfer any charge to your hand. Then I pulled the tapes away from each other. I could tell the tape was then charged, since when I brought my hand close to the tape, it would float closer to my hand. To test this again, I made a plastic pen negatively charged, then brought it close to the tape. The tape again floated towards the pen. I then brought the pieces of tape close to each other, at which point they repelled. I then measured and recorded the distance between the two pieces of tape. So my assumptions for the procedure are that we assume that Coulomb's law actually works for our experiment and that our spheres are equally distributed on the surface. We assume that the U tapes have the same net charge. We treat the tapes as if they are charges at the center of the tape, and that the tape is treated as a point charge. And then even though it is small, just from a fan or the air conditioner running, air resistance is negligible. As I mentioned before, negatively charged objects attracted to the U tape, such as the pen in my hand, while the tapes repelled each other. My observations for the experiment. So my length of tape was about 0.2 meters. The width of the tape was 0.23 meters. A conversion factor, and then the distance between the floating tapes was what I measured when I put the two tapes close to each other was 0.017 meters. Finally, here are some calculations using the figures from the previous slide. I calculate the force of gravity on the U tape using the tape's mass and gravitational accelerant constant. I then use the electric force equation to calculate the charge of the U tape. This helped me find Q, which I then use to find the number of deficient electrons. I did this by dividing Q by the number of electrons. Finally calculated the ratio of atoms that release electrons. Here's my glow script model. After inputting my constants, I found the point charges and initially the graphical representations on the tapes. So at the bottom of this is the graphical representation of my experimental model. The top circle represents the top tape and the bottom circle represents the bottom tape. The first arrow is the force on the bottom tape by the top rope. The middle arrow represents the force of gravity, and the bottom arrow is the force of the top tape by the bottom tape. In conclusion, so if electrons are negatively charged and protons are positively charged, and the signs of their charges are reversed, then the tape's charges will be different, but the interactions of the tapes to have with the objects would not change. The tapes would still repel each other, and the tapes would attract objects with a negative neutral charge. Thank you.